Hello and welcome to this lesson. We will cover location services in Android development. In this lesson, we'll cover several options for determining a user's location. With the growth and popularity of mobile devices, a trend has arisen for location-aware applications. Most mobile devices allow for a multitude of ways to determine the user's current location, and this information can be very useful for a wide array of applications. Some applications may require the user location in order to utilize navigation. For instance, a driving application that would require the user current location in order to navigate them to a desired location. Sometimes the requirement is to track a user location in order to see where they have traveled. For instance, in the case of a health or running application that tracks a user's travel when on a jog. Sometimes the simple distance between the user current location and a desired location of a store or outlet can be essential to an application, and these distance metrics can be obtainable in location-aware applications. Obtaining user location for a mobile device can be complicated. There are several reasons why a location reading, regardless of the source, can contain errors or be inaccurate. Some sources of the errors or the complexity in the user location can include a multitude of location sources. GPS, cell ID, and Wi-Fi can each provide a clue to the user's location. Determining which to use and trust is a matter of trade-offs in accuracy, speed, and battery efficiency. User movement. Because the user location changes, you must account for movement by re-estimating user location every so often. And varying accuracy. Location estimates coming from each location source are not consistent in their accuracy. A location obtained 10 seconds ago from one source might be more accurate than the newest location from another or even the same source. The Location Manager class provides access to the System Location Services. These services allow applications to obtain periodic updates of the device's geographical location, or to fire an application-specific intent when the device enters the proximity of a given geographical location. This will allow applications to access location data collected from data sources like the GPS of a device, Wi-Fi locations the device has scanned, and cell towers the device has recently used. In order to obtain an instance of the Location Manager, you do not need to initiate the class directly. Instead, it should be retrieved by calling context.getSystemService with the parameter context_location_service. In order to utilize the Location Manager, certain permissions are required to be declared in the Android manifest for the application. For instance, access course location, which allows an application to access approximate locations derived from network location sources such as cell towers and Wi-Fi, and access find location, which allows for an application to access more exact location parameters derived from cell towers, Wi-Fi, and GPS location positioning. One of the powerful tools in the Android development environment is the component of Google Play Services. Google Play Services allow applications access to an array of features through the integrated system. Google Play Services work through updates of an APK or Android application package that exists on most registered Android devices. This APK, which is called the Google Play Services APK, is updated from the Google Play Store with additional features and bug fixes. Your application can access these features through communication with the APK, as seen here in this diagram. Some of the features that the Google Play Services can provide are a variety of location services, which we will see shortly. APIs to ads and the usage of ads in applications, authentication components, APIs for Google Cast and Google Fit, as well as a list of gaming APIs like leaderboards, achievements, and multiplayer. The Google Play Services also include extensive APIs to maps and map-related features. There are plenty of additional features and APIs connected to the Google Play Services, and they are constantly updated with additional APIs being added and fixes for currently added APIs. Through the Google Play Services, we have access to a fused location provider. This provider will intelligently manage the underlying location technology and give us the best location according to the defined requirements. In association with the location provided, there are a list of simple APIs that let us specify high-level needs like high accuracy or low power, instead of having to worry about location providers. The location provider also gives applications immediate access to the best, most recent location data. It was built for power efficiency and minimizes an application's use of power. Based on all incoming location requests and available sensors, the Fuse location provider chooses the most efficient way to meet those needs. The Fuse location provider is also extremely versatile and meets a wide range of needs, from foreground uses that need highly accurate location to background uses that need periodic location updates with negligible power impact. Geofencing is a virtual barrier defined by GPS coordinates. Defining geofences is commonly used in applications to determine whether a user has entered or left a specific geographical region. The geofencing APIs in the location provider allow applications to set up geographic boundaries around specific locations and then receive notifications when the user enters or leaves these areas. These APIs are simple but powerful and allow batch addition and removal of geofences, ability to manage multiple geofences at the same time, and the ability to filter alerts for both entry and exit or entry only and exit only of these locations. As with the rest of the location services provided, the geofencing APIs are optimized for battery life. They are made to adjust location updates based on users' proximity to geofence and users' modality, still walking, driving, and so on. In addition, through the Google Play services, we can monitor activities like walking, running, or driving, or riding a bicycle through these APIs and associated API calls. When running an application on the emulator, we can simulate location through the Android Device Monitor, or DDMS view. When we open the Android Device Monitor from Android Studio, there is a view called Emulator Control. This view, which is seen here, allows us to simulate telephony statuses like receiving a call or SMS, and also location updates. By using this tool on an Android emulator, we're able to simulate location changes in an application and test the location component of that application. Now let's take a look at location services in code in Android Studio. In this example for location services, we will monitor a user's location using the Location Manager class. Let's first take a look at the Android manifest for this example application. We see that we have a permission declared in our manifest. This is important when utilizing the Location Manager service in Android. In this case, we have declared the usage of the permission for Access Find Location, which will allow to access precise location from sources such as GPS, cell towers, and Wi-Fi. In case we don't need such precise location data, we could declare the usage of the permission for Access Coarse Location, which would allow us to access approximate location derived from network location sources such as cell towers and Wi-Fi. Since we would like to run the application on the emulator and utilize the Android Device Monitor mock locations, we have declared the precise precision for this usage of permissions. We can see in the layout for our main activity, we have a simple text view with the ID TV location. We will write the location data to this text view. So let's take a look at the Java code for our main activity. In our main activity, we have a few constants declared for the minimum time and minimum distance parameters of location updates request, as well as member objects for our location manager, our text view, and a location listener. In our onCreate method of our activity, we grab our text view and grab the location manager from the system services. In our onStart, we initialize the location listener and request updates to this listener based on our previously declared constants and using the GPS provider. Note that when we get a callback for our on-location change, we set the text of our text view to include the location longitude and latitude rounded to 2 decimal points. We don't want to forget to stop updates to this listener once our activity is stopped, which we do in our onStop method callback here. In the case that we need location updates when the activity is not running, this is better accomplished through a service or another background-oriented task. Now let's run the application and see how we send mock locations to this application running in an emulator. We see that when the application starts running, we have a blank screen because we have not yet sent any location updates to the emulator. If we open our Android Device Monitor, we can find the tab for the emulator control. In the emulator control, we have control over location using manual input of locations, GPX data, and KML data. If we go into the manual input, we can enter a longitude and latitude and then send it to the device. And if we send it now, We see that the text view is updated with those locations to the 2 decimal places. We can also send a new update and see that the information is updated accordingly. Thank you for joining us in this lesson on location services. Join us in our next lesson where we'll cover motion and additional sensors used in the Android development system.